Back to topic 6C, solving quadratics by square roots. So we're going to start our solving quadratics this week as well. So today's essential question says, how does solving x in a quadratic functions compare to solving for x in linear functions? I actually want to start off with a review of x-intercepts from our linear unit, if you remember way back to our linear unit. Right, so first problem here says y equals 4x minus 12. So if you remember, y equals 4x minus 12. To find the x-intercept, we set y equal to 0 and solve for x, right? So if we make y 0, we have 0 equals 4x minus 12. Right, for this problem, I would add 12 to both sides. So I would have 12 equals 4x. Divide by 4, divide by 4, I would have x equals 3. So the x-intercept is when x is 3, y is 0, right? That would be the x-intercept for this problem. We also had problems, this was in y equals mx plus b form, right? Slope-intercept form. We also did problems from standard form, right? Same thing, we're still going to define the x-intercept. We make y 0 and solve for x. So I have 6x plus 0 equals 12, which is just 6x equals 12. Divide by 6, divide by 6, x equals 2. So this is 2 comma 0, right? The same process is what we're going to use, the initial process at least, is what we need to use for quadratics. It just gets a little more complicated now because we have these squared things. So in quadratics, y equals ax squared plus bx plus c, right? X and y are points on the graph of a parabola. I keep emphasizing this vocab, making sure we remember that this is a parabola. Right? So we looked at, in 6a, we looked at these parabolas and what these points are, right? So this here, one here, and this point here are our, let's put it inside, right? These 2 points here are the x-intercepts, right? Where they cross the x-axis. This point down here, if you remember, is our vertex. We also have a point here, that's our y-intercept. Right? Those are all very important points on the parabola. So what we're going to worry about today is we're focusing on solving quadratics. So to solve a quadratic, we are being asked to find the x-intercept. So if you're asked to solve a quadratic, you're being asked to find the x-intercepts. For quadratics, these are called roots. We call them the roots of the quadratic, or we call them the solution. So when we say we're solving a quadratic, the solution is an x-intercept, or we call them the zeros. Right, so if you remember back when we defined x-intercepts, I wrote down root, solution, zeros next to x-intercept. Any of these words can be interchanged for x-intercept. So whether I find the roots, the solutions, the zeros, all of it is x-intercepts. This is 0 if you can't quite read that. All right, so to find these x-intercepts, let's write x-intercept one more time. Or roots, and I'm focusing on roots today because we're using square roots to find them. So we set y equal to 0 and solve for x. So just like linear, right? Linear, we set y equals 0 and solve for x. It's easy in linear because x is to the power of 1. For quadratics, it's a little more complicated because x is to the power of 2. So remember, we are looking at, so if we have y equals, this equation up here, right? Y equals ax squared plus bx plus c. What we're doing is saying a 0 equals ax squared plus bx plus c. That is what we are doing. So looking at number 1 over here, here's our first problem. X squared equals 16. Right, this, I said first, let us look at some problems that already have y set equal to 0. So these ones, there is no y anywhere. So we don't have to worry about the setting y equal to 0. We're just solving for x. I want us to start by focusing on just the solving for x part of this. And so we're looking at x squared equals 16. Now the inverse, right? The inverse of square is the square root, right? So we're doing inverse operations. Up at the top, right, we were doing inverse operations. We were the opposite of minus 12 was plus 12, right? And then we inverse of multiply by 4 is divide by 4. So it's that same idea in solving. Here, we're still going to be using inverse operations. So the inverse of x squared is square root. So we're going to take the square root of both sides. That's how we're going to get x by itself, because we need to get x equals. That's our goal, is to get x equals. Now, this is where it gets a little tricky, right? Square root of 16 is 4, right? So we know that. But what we don't know is this. If we do it backwards, if I look at this as a backwards problem, I know that 4 times 4 equals 16, right? But I also know that negative 4 times negative 4 is 16, right? So we don't know if the answer is positive or the answer is negative. So when we do this plus or minus, or when we do the square root, we need to make sure that we have the plus or minus. Because as we saw up here, right, we have two solutions a lot for x-intercepts. So a lot of times there are two x values that work for this. This is where we get that 2 from, right? We have the positive version and we have the negative version, or the negative. We don't, it could be one, it is one and it's the other. So we need to make sure we capture both. So let's make a note of that we must include the plus and minus. The plus and minus. You have to have them both. When you take the square root, we need the plus or minus. Now, I'm going to make another note down here. I'm going to change over to green just to change it up a little bit. So if we are looking for solutions, so if looking for solutions, so if we're doing like we ask you to solve this, then x plus or minus, whoops, let's put the equal sign in there first. X equals plus or minus 4 is the answer, right? This is the solution. But if we're asked for the x-intercepts, this is a distinction we need to be careful about. Because if we're asked for x-intercepts, right, then our answer would be 4, 0 and negative 4, 0. X-intercepts are points. So you got to list them as points. So when we're talking about the graphs, or we're finding things on the graphs, we want them listed as points. If we're asking you for an x-intercept, we want it as a point. If we're asking you just to solve, you can just write x equals. Because usually x equals a number is an equation of a line, and that does represent. But if we're asking you just to solve, then we're fine with you just telling us what the values that are for x. We don't need you to write them as x-intercepts. That's an extra step that's not really required. But this is a key distinction. So for all these solving problems we're solving today, next week's all solving, you can just write x equals the answer. You don't have to write it as x-intercepts. But if you have a graph or you're asked to identify an x-intercept, then you should be listing the 2 points that x represents. And the y for both of those points is always 0, because 0 is always the y coordinate for an x-intercept. Okay? All right, let's look at number 2 then. So number 2, got a little bit of work to do, right? It's a little bit more complex of a problem here, right? So this is just like a solving problem. We still got to get the x term by itself. So I would add 2 to both sides here, right? I would have x squared equals 36, right? At this point now, I can get the x by itself. So I'm going to take the square root of both sides. A 36 is a perfect square. It is plus or minus 6. Square root of x squared is x. Here's my answer, x equals plus or minus 6. All right, that's what we're doing today. So we have a few more problems to do on the next page. Now, for our notes, for this unit, for these notes and these square roots, I've only given you perfect squares. So I'm not giving you any problems that don't. But there are, in fact, often non-perfect squares for our answers, and we will see those when we work on the quadratic formula. Next week, we will see lots of radicals in our answers, but for today, everything I'm giving you, it should factor into perfect squares. So we'll not have radicals left over. Okay, all right, so here we go. This is a little bit different. It's x minus 4 all squared equals 25, right? So we can't get rid of the parentheses until we need to get rid of the parentheses. We need to get rid of that squared out front because it's this whole thing squared. So we need to take the square root of the entire thing, right? By taking the square root of the entire thing, right? This 2 here cancels out that 2 there and leaves us with x minus 4. And then the square root of 25 is plus or minus 5, right? Now we still need to get x by itself. So we have, whoops, why am I writing an x there? We need to add 4 to both sides, right? So then we have x equals plus or minus 5 plus 4. Now, at this point, we need to figure out the two solutions because we have more work to do. So I'm going to say x equals positive 5 plus 4, which equals 9. So one of my solutions is 9. And then for my second solution, I'm going to do x equals negative 5 plus 4. Negative 5 plus 4 equals negative 1. Right, so my two solutions, and usually we list the solutions from smallest to biggest, so I would say negative 1, 9. Here are my solutions to this. These are the two. It's not plus or minus the same number because we had to add that 4 to both of the problems. Right, so since we had to add the 4 to both problems, my x is negative 1 and positive 9. So if you can do that math, you need to do that math. We need to get it down to a number, a single number, two single numbers for our answer. Okay, let's do another one like this one, because I think these ones are the ones that can be a little bit more complex. Let's look at one more like this. It's not always intuitive, right? So we have x plus 3 squared equals 81. So we need to get rid of this squared by taking the square root of both sides. That's going to bring the x plus 3 out, equals plus or minus 9, because the square root of 81 is 9. So that is a perfect square. The radical went away. And then I'm going to subtract 3 from both sides. So I have x equals plus or minus 9 minus 3. So we have to do both versions. We have to do x equals 9 minus 3, which is 6. And I need to do x equals negative 9 minus 3, which is negative 12. So x equals negative 12, comma 6. If you don't put them smallest to biggest, I will not mark you wrong, but I typically will write them smallest to biggest. Okay? All right, so that's just if there is no y, it's already set up to solve. You're asked to solve to find the solution. That's how you're going to solve it, right? This is just solving without thinking of the y. Now let's look at the y, right? So here we go. We actually have a quadratic equation. Y equals x squared minus 100, or x squared minus 100 equals y. So first step is to rewrite it with y is 0, right? So we can't solve it until we get rid of the y, looking for the x-intercept. So we are looking for something comma 0. So we plug in the 0 for y, and now we can solve, right? So now I have x squared minus 100. I add 100 to both sides. Just showing the work here. X squared equals 100. Now to get x by itself, we're going to take the square root of both sides. So square root of x squared is x. Square root of 100 is 10. There we are, right? So you've got to set it equal to 0. You need to show that math, right? There's no magic in math. So show that setting it equal to 0 and then solving it. All right, let's do number 6. Number 6 looks a little bit more complicated. So let's just start by getting it set up, right? This is a quadratic equation. So I'm just going to say x minus 4 squared minus 64 equals 0. Right, we can't take the square root yet because we can't take the square root until the parentheses thing is on the side by itself. So first thing we need to do is move this 64 to the other side. Right, so x minus 4 squared. We need this all by itself in order to take the square root. Right, now that it's all by itself, we can do the inverse operation of squared to get rid of that squared, do the square root. So now I have x minus 4 equals plus or minus 8, right? So you've got to move, if there's a c term connected to that, you've got to move that over first. And then we add the 4 to both sides. So I have x equals plus or minus 8 plus 4. You need to give me the two solutions. So I have x equals 8 plus 4. That's just 12. And x equals negative 8 plus 4. which is -4. So my answers are x equals -4 and 12. All right, so plug in 0 for y and solve. That is what we would do. That's where we go to keep working on these. All right, now, one last thing. Excuse me. What happens when? Here we go. I'm going to take a square root here, right? So look, I'm already set up to square root, right? It's already solved for. So I'm going to take the square root of this left and the square root of right. Now, when we get to this point here, and you have a negative under the radical, we cannot take a square root of a negative number, right? So I'm going to make a note here. So we cannot take a square root of a negative number. So if you have a negative number under the radical at any point, we stop working and we say no real solution. Again, it's no real solution. If you remember back and we talked about x-intercepts in our 6A notes and we were defining them, and I said you have two solutions, one solution that's the vertex, or no real solution. It's no real solution because there are imaginary solutions. There are ways to take that negative out from under the radical. We are not going to deal with those this year. It's imaginary number line. So we're just going to say there's no real solution. We're done. So anytime you get a negative underneath the radical, stop working, no real solution. Which is kind of nice. You're done. There is no, it is not, this parabola does not cross the x-axis, right? It is a parabola, I don't know exactly, right? It's a parabola that's up like this, or it's a parabola that's down like this somewhere, right? It could be over here, it could be over here. Oh, not that way. Whoops, did that one wrong. Could be up here. It could be on, right? It could be on here, it could be on here, but all these ones down here, right? They're below and they go down. All these ones up here are above and go up. None of them cross the x-axis. That's what's happening here. All right, so we got one last problem, right? So here we go. This one is not ready to solve yet because we need to make the y 0. So I have 0 equals x squared plus 81. Now we subtract the 81 from both sides. I have -81 equals x squared. Now that I got the x term isolated, I can take the square root of both sides. But again, there's a negative under the radical. No real solution. Right, so that's how we identify those no real solutions. All right, there we are. That's our notes for topic 6C, all on solving square roots. This is the first step on solving quadratics. Next week, we're going to learn how to solve by factoring and solve by the quadratic formula.